Yeah, so we've had a long history at NASA of developing robots for a lot of different things, but one of the things we're interested in now is how can we use robots to improve the way that humans can live and work in space. On the space station, for example, humans do a lot of routine, repetitive things. Well, most of us would call them chores. Doing inventory, checking the environment, looking at air quality, radiation levels, sound levels. Those things actually take up a lot of time, and we'd like to try to offload that work from humans to robots. About 3 years ago, we started developing this free-flying robot, the Smart Spheres. It started off life as just the sphere part here, which is a motion platform developed by MIT about 10 years ago, really to simulate satellites. Well, my group's a robotics group, so we said, well, let's turn this motion base into a free-flying robot. And so we added a smartphone, and the combination of smartphone plus spheres becomes the Smart Spheres. And we were actually really excited by the whole development of the smartphones, not for making calls, but as a real high-performance embedded computer. When we started working with the system, for example, we inherited this base here, the red satellite here, and it didn't have a high-performance processor. It didn't have wireless data transmission at high speed. It didn't have cameras. Didn't have a variety of things that make a robot a robot. And when we started sitting down and figuring out what do we need, we said, well, we need Wi-Fi, we need a processor, we need a GPU, we need a touchscreen display, and we want it compact, and we want it to be low power, and we want it to be rugged. And people are sitting in a room, everybody's got their smartphones up and saying, boy, I wonder what kind of device could do that. It made perfect sense to look at using smartphones.
So the astronaut, first thing he does when he pulls a sphere out of the drawer, screws in CO2, goes up to the regulator, and then goes and tunes it to 35 psi. And all these little silver spots you see on the sphere, these are actually the thrusters, and there's 12 of them on the sphere. They fire in pairs of 2, and this is how the sphere moves. And it just lets out a little jet of CO2, and it moves very slowly. And that's about 0.1 newtons of force is what spheres can apply. We had a problem for spheres is it only works in a small region, a 2-meter cube. It's like 1/5 of a single module on board the space station. And we just said, man, it'd be really great if we could go and navigate the whole space station. And so we're like, well, it needs to be vision so we don't have to rig the environment. And man, vision's hard, and that costs lots of money. But then it turns out that Google had already developed the technology. And then we looked across the street and saw that Google was developing Project Tango. And Tango is a cell phone that does vision navigation, which is essentially going to be like the best GPS you've ever had. GPS that would work anywhere. It's indoor. And so instead of just giving you a long lat location, it gives you XYZ and also your orientation, your roll, pitch, and yaw. And it does all this at video frame rates. And so we asked them to make a space-rated version of it. And that's where this device comes in. And this is just showing you a depth image. So the color represents distance from the camera. As you move your hand around, the color change tells you where it is. By combining Project Tango with Sphere, we now hope to allow spheres to now navigate the whole space station, being that it has vision navigation.